Welcome to Lesson 6, the final lesson in this course. You'll be using the postchain-client to interact with your blockchain Dapp. You'll set up the environment, connect to the chain, and implement functions to query data and send transactions. You'll be working in TypeScript, giving you building blocks of code you can adapt to either a front-end or a back-end application. Let's get started. First, we'll look at the environment and make sure you have Node.js installed. Let's quickly head over to the official website. We want to download. I'll leave the version at 22, which is currently the latest long-term support, but I'm on Linux, so I'll select that. And NVM. And finally, copy the whole thing. Okay, it turns out I already had it installed, but now we're sure. Next we'll do a project folder. Not inside the existing project. There we go, and open it in your preferred editor. Let's initialize it as a Node.js project. And install dependencies, the essentials being TypeScript and especially the postchain client. Alright, we also need a TypeScript configuration file. And there we go, it's right here. And here are the instructions for compiling and running the code once we have something to work with. Let's continue. First we'll create the file bookreview.ts. And place the imports at the top. We'll need a main function. Let's skip the empty one and immediately implement the client. We have to tell the client which nodes to connect to and which blockchain to work with. In this case, we're connected to our local node, which we're going to query for information about the blockchain. I'm just adding a line break so the bridge's easier to copy. But hey, we didn't spin up the node yet. Let's do that. Back in our book review, we'll start a clean node with our Dapp. This is the bridge we're looking for, EFA 90. And we can now confirm that we got the correct bridge. Let's provide it to the client. You might remember that we need to sign as the book admin to do any operations, so let's prepare that. For simplicity, we're providing the private key directly. If you've been following the course instructions, you'll find it in your user directory under .chromia in the book admin file. Again, I'm adding a line break at the end to make the key easier to copy. As I mentioned, this is mainly for simplicity, but I do recommend studying best practices around key management in the documentation. But let's finish our approach by setting up the signature provider. Next, we're going to sign and send a transaction. In addition to signing, we of course need to specify which transaction we're sending and what arguments we're passing. So to summarize, we're choosing an operation and its arguments, signing it as a transaction, and sending it to the blockchain. Let's go ahead and see if it actually works. Here we'll just call the main function and compile and run. Alright, great. The transaction went through, but we're also seeing a Merkle hash warning. A recent update introduced version 2, so you see this warning if you don't explicitly set which one you're using. Version 2 is recommended, so let's go ahead and set that in our book review right away. It's here in the Chromia YML file. Under our book review blockchain, we're adding a config section with features, and setting Merkle hash version to 2. And then we just need to restart the node with our new configuration. Alright, let's try again and see if the warning disappears. Oh, of course. When we restarted the node with an updated Dapp, the BRID also changed. We'll need to set the new BRID to correctly target the blockchain. Alright, ready for one more try. Just need to compile. And fortunately, as expected, we created the transaction without the warning. Now let's create some queries as well. We'll start by defining a book type. You might remember it matches the structure of our book entity in rel, and it helps us work with the results when we query the blockchain. And here's the query to get all books. This time we don't need to sign anything, but we do need to provide the name of the query along with the arguments. And we're just adding the query to our main function. There it is. Restart and wipe the node so we don't get duplicate transactions, and then we can proceed. Okay, let's compile and then try it. And indeed we got the list of books. But if we try one more time, because our main function keeps adding the same book, we're getting a duplicate key error. Either we need to change the books we're adding or restart and wipe the node. Now let's continue the lesson as the node is starting up. Next, we're adding a type for book reviews that will help us with the query results. After that, we'll add some helper functions and additional queries, including getTransactions, which queries the system entity of blockchain transactions. And finally, there's a comprehensive main function that tries several different transactions and queries so we can verify that everything works. That was the full code. What's left now is just to compile and run it. Okay, let's see. Fantastic! It really looks like everything is working. Let's just do a final side-by-side comparison of the transactions. You may recall the getTransactions query. In any case, we have it right here. And now we can really compare. If we scroll a bit, we can see the exact same arguments on both sides. Let's check this signature, 13C7A8. Yes, it matches perfectly. And here's another transaction with the same arguments again. So there it is. Our test of the postchain client is now successfully verified. Well done! If you followed the course and done the work so far, you now have the tools to start creating on your own. Whether you already have an idea in mind or just want to explore what's possible, our community is a great place to keep going. Join our Discord to connect with other developers, get feedback, and find support whenever you need it. We'd love to hear what's on your mind. Seriously, you've come a long way. Not everyone makes it this far. Great job! And thank you for joining me. I'm genuinely excited to see what you'll build on Chromia. See you in the next video.